When working with variables like this integer e here, we use this thing called an assignment operator, which looks like a mathematical equals sign, to give that e some sort of value. And we've worked with this for a while, so this is no surprises here sort of stuff. We see out e to the screen just to see that it works. We're not surprised either that a 5 prints out to the terminal screen because, after all, e equals 5, and then we print out e. Well, there's our 5. And so, with all of this evidence in front of you, that this thing symbolically looks like an equals sign, and contextually it works the same as the equals sign does, and we've even printed out for verification that this value did get passed into E, you may think that this is identical to the mathematical equals sign, but it's not. And there's some important nuances here to realize that both hinder you in your coding, but also benefit you, and we can use some of these things to our advantage in the future if we understand the nuances of how the assignment operator works versus the equal sign. And so, one of the most illustrative points that I can probably make is that there's an order here to the operations of how things work with this assignment operator. So, for instance, mathematically, if you had a statement like e equals 5, then you could also say that 5 equals e. If you have two things that are equal to each other, it doesn't matter in which order you list them. They're still equal to each other, and so both of these statements in math would be equally valid. But when you run this in C++, well, it's got an issue with this second line here, and there's an error, and this error message down here is pretty cryptic. It says L value required as left operand of assignment. So what's going on here? Well, this thing right here, once again, is called an assignment operator. And it's, in general, just a type of operator. And if you're an operator, well, you need things to operate on. And the things that you operate on are called operands. And well, this particular operator has two operands. It has one on the right-hand side of it, and it's got one on the left-hand side of it, right? Now, because this operand over here is on the right-hand side, it can also be called an R value in parlance. The one on the left-hand side is, you guessed it, also called an L value. And there's restrictions on what type of things can be considered R values and what type of things can be considered L values. And it has to do with the directionality of how this thing works, because it always takes the thing from the right and pushes it into the thing on the left. So, that being said, this top line sort of makes sense. We have this variable e over here that can be any integer. As long as it's an integer, it can be -7, it could be 0, it could be 4 million. And we have this specific integer on the right that we're pushing into this thing on the left. So we're taking a specific integer 5 that's stuck being 5. It's very specifically 5. It's hard coded that way. And, we're taking something small and specific, this 5, and we're pushing it into something that's big. It can be any integer. And we're taking a small thing and pushing it into this big thing, and it doesn't make a whole lot of sense when you think about it the other way around, when you're taking this big thing and pushing it into this small thing, when you realize the directionality of how this assignment operator works, taking the right thing and pushing it into the left thing, right? And because of this directionality, the thing on the left, this L value here, has to be some sort of data structure that can contain information like a variable, for instance. And so, well, we can change this. It doesn't have to be this hard value 5 on the left. For instance, we can create another variable like d. And now this is actually perfectly fine. And we see that it runs, and to prove that it runs correctly, we can see out to the screen the value of d here. And we see that, well, there's hard value 5 is being pushed into this e variable, and then, well, now you can think of the e variable as a placeholder for 5. So anytime that you see e, you can think mentally 5. And so mentally, you can replace this e down here with that 5. And now it clears it up. You see that the syntax here is identical to the line above it. It's just different variable names. Now we have d equals 5, and now we have e equals 5. And so that's essentially what's going on here. This 5 gets pushed into this e. This e is a placeholder for 5 now. And, well, now this 5 gets pushed into this d. We're just passing it along from right to left. And when we run this, well, you see that there's both of our 5s, D and E. And you don't even have to do this one at a time, as it turns out. You can do a long string of these. So we can have integers A, B, and C, for instance. And then we can have another line underneath, like A equals B equals C equals D. And then we can see out to the screen A and drop down a line. And then we can see out to the screen B and then drop down a line. And then we can also see out to the screen C and drop down a line. And, well, we should see this pushed the entire length of all of these variables, essentially. We have a long line of 5s here that starts off at E, 5 getting assigned to E. Now, E is a placeholder for 5, which gets assigned to D. Now, D is a placeholder for 5, which gets assigned to C, which gets assigned to B. But notice we're working from right to left here, as always. And when you have a long string of them, you just start at the extreme right and still work your way to the left. So 5 gets pushed into D, gets pushed into C, gets pushed into B, and so forth, until the string of variables entirely equals 5 individually. And once again, we can see this with the 5 5s here. Now, one of the other differences that I wanted to point out between the equals sign in math and the assignment operator is this. Now, consider this in algebra. We have A equals A plus 1. Now, consider this statement here. This really doesn't make a whole lot of sense in algebra. It's an invalid statement, and we can see that intuitively if you just plug in a value real quick. We can say 4 equals 4 plus 1 if we made A equal 4 here, and so, well, that just simplifies into 4 equals 5. And, we see that this never makes sense for any value. We can generalize this and just solve this algebraically, for instance, by, well, first we'd have to subtract A from both sides of the equation. So this would be A minus A equals A minus A plus 1, right? And then, well, anything subtracted from itself, as is the case here with A minus A, is just 0. So we have 0 equals, and, well, we have another A minus A over here, so that's 0 once again. And then we have this plus 1 left over, so we'll just toss that on in there. And then when we simplify this, we end up with 0 equals 1 as a general statement. Which, once again, is an invalid scenario. You can't have this in algebra. That doesn't make any sense. However, in programming, this actually makes sense, believe it or not, because this is an equal sign. It's an assignment operator. So, because an assignment operator takes the operand, if this is our assignment operator, and it takes the operand that's on the right, well, this operand that's on the right is A. Well, that's a 5 because 5 got passed down through all of our variables. That's a 5 plus 1 on this side, so that's just a 6. And then we take whatever's on the right and assign it into the thing on the left. So now A equals 6. And we can sort of prove that by outing A to the screen and running this. And then at the end of our long lines of 5s, we got a 6 there. So that's from A equals A plus 1. And of course, you don't have to increment it by 1. You can increment it by 5, for instance, and do whatever you wish. So it works exactly the same. As a matter of fact, this works with all of the mathematical operators. So it can be A equals A minus 5, A equals A times 5, whatever. And furthermore, there's a shortcut for this. So instead of A equals A plus 5, for instance, an equivalent but shorter statement would be A plus equals 5, right? Just a little shorthand that you can use. And I know this doesn't make sense at all mathematically, but this is something that you can do in C++. And just to show you that it works, there's our 10 still there. there. We commented out the original a equals a plus 5, so that doesn't work at all anymore. Now we just have a plus equals 5. And this works no matter what mathematical operation that you're using. Any of the basic mathematical operations work like this. So a equals a minus 5, so that would be a minus equals 5. Now you can also do a times equals 5. You can do a divided equals 5. You can even do a modulus equals 5. And it all works exactly the same as a equals a minus 5, or a equals a times 5, or a equals a divided by 5, or a equals a modulus 5. So just wanted to illustrate some of the differences between the equals sign and the assignment operator in C++, and clarify some things and show you this shortcut. So see you in the next one.